preparation of IV fluid under laminar flow by neonatal intensive care unit personnel. This is prepared by Department of Neonatology, SSKM, Kolkata. Total parenteral nutrition may be defined as provision of nutrition for metabolic requirements and growth through the parenteral route. To maximize benefits and minimize complications, many centers across the world now prepare the total parenteral nutrition through a centralized pharmacy. However, in the Indian situation, it is the physician who has to take over the roles of this preparation. Total parenteral nutrition is technically demanding, it is expensive, and has got several side effects. The objectives of this demonstration are basic indications about TPN, basics of laminar flow machine, cleaning the laminar flow machine, operating the laminar flow machine and preparing TPN, and calculating TPN for a certain patient. A TPN solution contains proteins as crystalline amino acids, fats as 20% intralipids or 10% intralipids, carbohydrates as glucose, electrolytes like potassium, sodium, calcium and magnesium, and certain trace elements along with. TPN is indicated in premature babies less than 28 weeks or babies who are less than 1000 grams, babies who are less than 32 weeks but are unable to achieve reasonable enteral feeds by day 3, infants more than 32 weeks or more than 1005 grams who are unlikely to achieve at least 50% enteral feeds by day 5, babies with necrotizing enterocolitis, and surgically correctable gastrointestinal tract anomalies such as exomphalos, gastroschisis, volvulus, short bowel syndrome, etc. Basics of laminar flow machine. In NICU environment, while preparing intravenous solutions, parenteral nutrition solutions or drugs, the product may get contaminated with particles as well as microorganisms found in the atmosphere. Laminar flow systems are useful for safe and aseptic formulation and mixing of drugs, intravenous fluids, and nutrients. A laminar flow cabinet provides a controlled environment in which the level of particulates, microbes, and contaminants of all kinds are regulated and kept to a minimum by constant air filtration with industrial grade filter. Basics of laminar flow machine. So, the principles of laminar airflow are that there is a twice filtered laminar airs of aseptic air which moves and it continuously sweeps the work area inside the hood, thereby preventing the entry of contaminated room. A laminar flow hood consists of a filter pad, a fan, and a HEPA, which is a high efficiency particulate air filter. The fan sucks the air through the filter pad. There is a pre-filter where the dust is trapped. After that, the pre-filtered air has to pass the HEPA filter where contaminating fungi, the bacteria, dust, etc. are removed. Now, the sterile air flows into the work area. So, the laminar flow cabinet creates a particle-free working environment by taking the air through a filtration system and exhausting it through a work surface in a laminar or a unidirectional air system. So, there are two types of laminar air flows. One, there is a horizontal laminar flow machine and there is a vertical laminar flow machine. The horizontal laminar flow is a machine where the clean air is exhausted across the work area in a horizontal laminar flow system, cleaning of the laminar flow hood. In the following section, we'll go through the steps of cleaning of a laminar flow hood. Because this is of paramount importance, until and unless the laminar flow hood is cleaned diligently, it can itself give rise to a number of infections and hazards. In the next section, we'll go through 7 steps which will ensure, if properly followed, that there would not be any hazardous complication arising of improper cleaning of the laminar flow hood. Step number 1 is to empty the waste buckets and remove any vial or syringe from the laminar flow hood left over from the previous use. Step number 2 is to clean the entire room, that is, if it is placed in a segregated room, along with the floor and the walls using a 2% bacillocid solution is that the front plexiglass cover should be cleaned with a warm soap solution. Do not, I repeat, do not use alcohol to clean the glass in order to prevent cracking or clouding of the glass. For the step number 4, clean the grill of the filter present at the roof, that is in the vertical laminar flow, or at the back, that is in the horizontal laminar flow, from back to front, or for that matter from up to down in a single parallel strokes, taking care that one stroke overlaps the other using a lint-free. The walls of the wood should be cleaned next from the above downwards direction using a separate lint-free cloth with the same technique of the overlapping strokes. Do the same now for the step number 6 in case of the floor, that is cleaning it from back to front. The last 3 steps should be performed twice using a lint-free cloth soaked in sterile water first and then another soaked in 70% alcohol. Now we come to objective number 4. This has actually got 3 parts. A. We will understand the steps of operating the laminar airflow. B. We'll also come to know how to prepare IV fluid under the laminar airflow. And finally, we'll know how to terminate the process and dispense this laminar airflow under aseptic process using a proper hub and line care. So the first step of operating the laminar airflow is basically to connect the machine to a 3-pin socket. The line indicator will glow by switching on the unit from the main switch. Step number 2 is the air supply should now be turned on at least 30 minutes before the use of the machine. Keep open the front door during this air so that the non-sterile air can now be completely replaced by clean sterile air. The first step is wiping off all necessary IV fluid bottles with Bacillons 25, which is basically a 70% alcohol solution, and placing them in the laminar flow bench. Take care to place them in the middle area of the bench between the perforated zones in case of a vertical laminar flow, that is, so as to not block the air circulation. The step number 4 is to remove the IV fluid drip sets, syringes from their outer commercial pouches and wrappers. Now place them in the same area within the laminar flow. Place all the other provisions except for the IV fluids and the MBI in the same zone. We are not keeping the IV fluids and the MBI initially because they are more photosensitive. This entire procedure should be done wearing sterile pair. Step number 5. Now switch on the UV light. This UV light will help in sterilization of the chamber. But remember to keep the door closed during this time. You should only start the UV light once all the products that you are going to use during your TPN preparation are within the safe confines of your laminar flow. Step number 6 is wait for 30 minutes for the work area to be complete. Step number 7. Switch off the UV light and switch on the fluorescent light. Step number 8. Open the door. For the next section, under the objective, we will show you how to prepare the IV fluids under laminar airflow. We'll go through a number of steps, of which the step 1 is that the 2 persons who are preparing the laminar airflow should always prepare IV fluids wearing sterile gowns, caps, masks and gloves after performing meticulous hand hygiene with hand wash, proper drying and even using alcohol-based hand rub. Remember to not keep any unsterile articles like pieces of paper or pens with. Step number 2. The personnel should also carry with them in the laminar airflow room a sterile container filled with spirit and a number of sterile gauze pieces and about 6 to 8 extra pairs of sterile gloves. This is done to ensure that any time the operator feels that he or she has touched anything remotely unsterile, they would have the option of changing their sterile gloves. For the step number 3, the personnel should sit on a low stool facing the laminar airflow hood with their arms up to the elbows inside the hood so that all the maneuvers they are carrying is carried out at least 6 inches inside the hood. At a distance less than 6 inches, the laminar airflow starts mixing with the outside air and contamination is step number 4. Hang the IV fluids from the hooks inside the hood, taking care to avoid clutter and ensuring the adequate space of at least 6 inches between the two successive bottles so the zones of turbulence of one doesn't overlap with the other. Attempts should always be made to avoid walking directly downstream from the above hanging bottles to prevent the possible contamination in case of the vertical laminar airflow. In case of the horizontal laminar airflow, one should avoid working just behind the hanging bottles. For step number 5, the gauze pieces soaked with alcohol should be used to cleanse the rubber caps of the fluid bottles after the plastic cap is removed. Now, one of the personnel should only be handling the bottle of the fluids, while the other only draws fluid through the sterile syringes and the burettes. Remember, hand cleanliness is further reduced each and every time more and more bottles and other non-sterile articles are handled. So, one of the operators will act as a clean operator while the other acts as a sterile operator. Hence, a habit should be made to change the gloves as and when required. Introduce only HEPA air from above in case of a vertical laminar airflow or from behind to introduce into the bottles in order to assist in withdrawal of the content. While introducing the needle into the vial, introduce the needle with the beveled end up at 45 degrees, taking care not to obstruct the airflow around the needle and the fingers. That is, the vial should be held vertically and the fingers should be placed in a way to allow unobstructed laminar airflow. Placing the fingers between the vial and the laminar airflow would obstruct the entry of the needle into the vial. Now remember, do not touch the critical surfaces. They are the needle shaft, opening of the hub, syringe tip, or the stem of the plunger. In fact, attempts should be made to not touch any surface other than the flat end of the plunger. Needles should be used for a maximum of only 8 to 10 punctures. Do not, we repeat, do not reach out of the laminar flow to discard the trash until finished. It is a good practice to use a bowl in which the extra fluid or the used needles can be discarded and kept within the laminar flow. In the next section, we are going to cover the termination of the procedure and how to dispense a properly made TPN. Initially, it has to be made sure a properly made label is attached to each and every bottle of TPN. The proper label should cover the name of the baby, the amount of fluid volume that is made, the date of preparation, and the composition of the IV fluid. Once it is attached, the person who has prepared the TPN should take the responsibility of carrying the composed fluids to the respective beds and take care to attach them to the IV lines. A strict hub and line protocol should be followed. That means the line or the hub shall be placed over a 4x4 alcohol soaked gauze or a sterile paper maybe, and then the hub should be cleaned with chlorhexidine 10 cm above and below the port for about 30 seconds. Objective number 5. How to calculate TPN. In this next section, we will learn how to calculate TPN and how to prescribe TPN. So initially, one should calculate the IV fluids and its components carefully. One should take care to multiply the total fluid requirement, that is the total parenteral fluid requirement, as calculated by multiplying it by 1.2, that is the requirement for 1 day plus 20% overfill. Here the overfill is for the wastage factor. Prescribing, one has to take care of the osmolality of the fluid. That is, one has to remember that central lines would bear for a osmolality which is more than 900 milliosmoles per liter and a dextrose solution which has got more than 12.5% concentration. For calculation, one can use these conversions. For each 1% dextrose, 55 milliosmoles per liter of osmolar load is contributed. 1% amino acid contributes about 100 milliosmoles per liter, while 1% NaCl will contribute 340 milliosmoles per liter. One should also remember lipids should only be calculated for about a day and infused by using amber colored pressure monitoring line. Remember to add heparin at the rate of 0.5 units per ml. Now we will go through 15 steps in order to calculate proper TPN. These steps initially begin with calculation of the total fluid intake. Calculation of the total fluid intake. In the step number 2, we will subtract the entire feed volume plus drug volume as well as the arterial fluid volume from the entire calculated total fluid intake to calculate the total TPN volume in mLs per day. In the step number 3, the lipid volume is calculated. One can use from 0.5 to 3.5 grams per kg per day of lipid. Generally 20% intralipid is used. Get the entire volume in ml following the formula in front. Step number 4, the volume of the glucose, amino acids and electrolytes as a cumulative is calculated, and it is calculated by subtracting the lipid volume from the total parenteral nutrition volume. In the step number 5, now we will calculate the amino acid volume. The amino acids that is generally being used is generally 10%. So we will multiply the amount that we obtained by 1.2, which is the wastage factor. Now in the step number 6, the sodium requirement is calculated. We will try to get the entire volume by using 3% NaCl, which contributes 2 milliequivalents per ml. For step number 7, we will calculate the requirement of the potassium. Keeping in mind, potassium chloride contributes 2 milliequivalents of potassium per ml. For the step number 8, we will calculate the requirement of calcium, which is generally provided through calcium gluconate. It is given in the dose of 4 ml per kg per day. If total parenteral nutrition is being infused through a peripheral line, one has to be extra cautious about extravasation if calcium gluconate is being used. There would be no such worries if a properly positioned central line is being used. For step number 9, we will calculate the amount of magnesium sulfate. Magnesium sulfate, that is 50% of magnesium sulfate, is generally used at the dose of 0.25 ml per kg per day. Remember to calculate the volumes of each of these electrolytes by multiplying each of them by 1.2, which is the wastage factor. So we have now got the total electrolyte volume. The total electrolyte volume is the sum total of the amount you require for 3% NaCl, potassium chloride, calcium gluconate and 50% magnesium sulfate. In the step number 11, we will calculate the amount which is required for the dextrose. In this step, we will calculate the percentage of the dextrose which is required. After finalizing the GIR, which is generally used from 6 to 12 mg per kg per minute, we will calculate the percentage of the dextrose using the following formula, which is GIR equal to percentage of the dextrose being infused multiplied by rate in ml per hour divided by body weight in kg into 6. Now, it may be so that the percentage of the dextrose that we require may be more than 10%, or it may be even 8% or 9%. That may be difficult to be provided using a standard 5% or a 10% solution. So we require another formula. The formula we use is made by using 5% and 25% dextrose, using a formula y is equal to 5x minus 25, where y is amount of 25% dextrose required to be mixed with 100 minus y ml of 5% dextrose to make 100 ml of x% dextrose. Step number 13. Now we will add 0.5 units per ml of heparin. In step number 14, we will add 1 ml per kg of MVI in the lipid. In the step number 15, we will calculate the rate of the lipid infusion and the rate of the glucose amino acid electrolyte infusion separately. We hope this entire demonstration has been beneficial to you in order to start total parenteral nutrition preparation under strict asepsis at your setup. Remember to maintain strict asepsis, including surgical scrubbing and gowning. Remember to use the sterile surface for mixing different constituents, preferably under a laminar flow. Remember to change the infusion sets every day. It is better if you use another line for administration of antibiotics and inotropes instead of the line which is being used for total parenteral nutrition. It should be emphasized that only trained personnel should make parenteral nutrition. Using of infusion pumps is a must for administration of the total parenteral nutrition.